Imagine standing on a silent, endless desert under a pale sky. The ground beneath your feet is rust-colored, dry, and lifeless. No oceans, no forests, no sound except the whisper of dust carried by a thin, freezing wind. This is Mars, the red planet as we know it today. But here's the question that changes everything. Was Mars always like this? Was it always a cold, dead world, or did it once look like something far more familiar? Let's go back in time. Not thousands, not millions, but hundreds of millions, even billions of years into the past. What you're about to see may completely change how you think about planets, life, and even the future of Earth itself. Prepare yourself. Your journey begins 100 million years ago. You arrive on Mars 100 million years in the past. You step onto the surface, expecting something dramatically different. But what you see is surprising. The landscape looks almost the same as today. A vast red desert stretches to the horizon. The atmosphere is still extremely thin, less than 1% of Earth's pressure. Temperatures still swing between roughly minus 13 degrees Celsius and 20 degrees Celsius. Radiation still bombards the surface. At first glance, Mars already seems like a dead world. But look closer. In the distance rises Olympus Mons, the largest volcano in the entire solar system, towering over 20 kilometers high. While mostly dormant today, during this era it may still have shown signs of minor activity. Beneath your feet, something else is happening, something subtle but important. Water. Not rivers, not oceans, but fleeting traces. The Martian soil contains chemical compounds that dramatically lower the freezing point of water. Under certain conditions, extremely salty liquid water could briefly exist, even at temperatures as low as minus 75 degrees Celsius. These briny flows would appear and vanish quickly, like ghosts of a wetter past. So even 100 million years ago, Mars was mostly dry, but not completely devoid of liquid water. Now, let's go further back. Much further, travel back 2 to 3 billion years ago. You might expect a blue world, but again, Mars surprises you. The atmosphere is still thin. Stable liquid water still cannot remain on the surface for long. Vast oceans are nowhere to be seen. But something extraordinary happens here. Without warning, the ground fractures. Massive underground reservoirs of water trapped deep beneath the surface are suddenly released by volcanic activity. What follows is unimaginable, catastrophic floods. On Earth, one of the largest river systems can reach about 300 cubic meters per second. But on ancient Mars, floodwaters may have surged at rates up to 1 billion cubic meters per second, over 3,000 times greater. For a brief moment, Mars transforms. Violent torrents carve enormous channels across the surface. Entire regions are reshaped in a matter of days. Then, just as quickly, the water disappears, evaporating or freezing, leaving behind only scars in the landscape. Mars is not stable. It is a world of extremes, a world where water appears and vanishes. But now we go to the most important chapter of all. Travel back over 4 billion years. This is where everything changes. Before you lies a completely different Mars. The northern hemisphere is covered by a vast ocean. Water stretches as far as the eye can see, with depths reaching up to 1.6 kilometers. The sky is thicker, the pressure stronger, possibly at least zero point 0.5 atmospheres. For the first time, Mars feels alive. In this distant past, Mars may have been one of 3 blue planets in our solar system, alongside Earth and Venus. Conditions may have allowed liquid water to remain stable for long periods. And where there is water, there is always a possibility: life. But this world was not destined to last. A silent force begins to strip Mars of its future, the solar wind. High-speed charged particles stream from the sun, crashing into the Martian atmosphere. Without protection, these particles transfer energy to atmospheric molecules, allowing them to escape into space. Over hundreds of millions of years, Mars slowly loses its atmosphere. As pressure drops, liquid water becomes unstable. Oceans begin to evaporate. Ice turns directly into vapor. Ultraviolet light breaks water molecules apart into hydrogen and oxygen. The hydrogen escapes into space forever. The oxygen remains and reacts with iron in the soil. This is where the red color comes from. Rust. The transformation from a blue planet to a red planet unfolds slowly between 3.9 and 3 billion years ago. What was once an ocean world becomes a frozen desert. Why didn't this happen to Earth? The answer lies deep within the planet itself. Earth has a magnetic field, a powerful, invisible shield generated by the movement of liquid metal in its core. This field deflects the solar wind, protecting the atmosphere and preserving the oceans. Mars once had a magnetic field too, but it didn't last. Mars is smaller, about half Earth's diameter and 1/10 its mass. Smaller planets cool faster. Its core lost heat quickly, weakening the internal motion needed to sustain a magnetic field. A layer of lighter material may have further reduced temperature differences inside the core, slowing circulation even more. Eventually, the magnetic field shut down, and with it, Mars lost its protection. Juan continues with a deeper reflection. Without a magnetic shield, Mars became vulnerable. Its atmosphere was stripped away, its water disappeared, its potential for life faded. What remains is a silent record of what once was a planet that may have briefly resembled Earth, but could not hold on to that identity.
Now return to the present. You stand again on modern Mars, a cold, dry, red world. But now you see it differently. This is not just a dead planet. It is a story frozen in time, a reminder that even worlds can change dramatically. Mars teaches us something profound. Planetary life is fragile. Even Earth, with its oceans and thriving ecosystems, is not guaranteed to remain this way forever. Billions of years from now, changes in the Sun may strip Earth of its water, just as Mars lost its own. Blue planets can become red, and what seems eternal may only be temporary on a cosmic scale. So as you look up at the night sky, remember this. Mars is not just a distant world, It is a glimpse into both the past and the possible future. The question is no longer what happened to Mars. The question is, what will happen to us?